is Phil Tsao, and I'm from Stanford University, and I'm coming to you from Vascular Discovery 2024, sitting here with this year's Jeffrey M. Hoeg Award winner, Dr. Chiara Giannarelli from the New York University. Chiara, congratulations.
Thank you. It's an honor and a privilege. Thank you so much.
Fantastic. And the Hoeg Award is given to someone who's in the height of their career and doing fantastic work, and certainly you are doing such. And your lecture's tomorrow. Would you like to tell us a little bit about what you're going to speak about?
Yes. Tomorrow I decided to talk about one of the latest stories that we have developed, and it's a story about how COVID-19 and SARS-CoV-2 infection affects atherosclerosis and increases the risk of cardiovascular disease. And this is a story that is very dear to me because, as you know, New York City was at the center of the pandemic. So it's something that, one of those experiences of a lifetime. And it really inspired me during those difficult times and motivated me into really thinking into study this problem. Early on, we knew about how SARS-CoV-2 infection increases risk for heart attack and stroke. And we really didn't understand how. I thought that there was some opportunity to know more about how this virus influence organ systems beyond respiratory systems. And the heart is what we study, atherosclerosis. So I decided to start working on this. And we discovered that beyond inflammatory responses that the virus elicits in systemically, there is a direct influence of the virus that it's capable of infecting cells within the arterial wall, particularly in diseased arterial wall. And we discovered that macrophages are important players and identified a particular tropism of SARS-CoV-2 for lipid-rich macrophages, really laying the ground for new discoveries that I hope the community will start looking into.
That's very interesting. You've been studying atherosclerosis for a while,
yes.
And so you brought many new tools to the field.
Yes.
So could you maybe give us an example of one of your favorite tools that really helped you gain insight into the role of SARS-CoV-2?
Mm-hmm. So yeah, it's true. I really got interested into technologies a few years ago. At the time, I was transitioning from my K award into the R1, and there was an opportunity at the institution I was at to start using very early on single-cell technologies. And I decided to invest my time into developing this program, and with some, difficult times in some moments, not everything works at the first time. But I felt that it was really an important opportunity to understand the implications of different immune cells and other cell types working as an orchestra and overall and not as single players into human disease. I'm a physician by training, so I always try to identify the opportunity to study human tissues and to understand biology. And that was my motivation. And my lab really works a lot using these technologies. And we didn't have the opportunity to study the materials that we were able to collect at NYU. And I'm referring to autopsy specimens using single cell technologies, but we used additional new tools consisting of RNA-scope or technologies that allows you to really quantify in these tissue sections viral RNA. And the analysis was something that was really important to me to do very rigorously. So we decided to implement a digital pathology approach that it's really unbiased and allows you to quantify with very much rigor and lack of bias what we were finding in this specimen. So this was for me a very important basis for the research. And as we discovered about macrophages and their role and how they could be infected, we decided to understand more. And we used the single cell technologies at that point and identified that the entry of the virus into macrophages is at least in part dependent on the expression of a receptor that's called neuropilin-1 that was reported early on during the early month of the pandemic as an important viral entry factor by others in two back-to-back publications in Science. And we discovered that this receptor is implicated in within the cardiovascular system as well. And we were able to see that by blocking this its expression or pharmacologically targeting the receptor, we were able to reduce the infection of these cells. So this was a very important finding to discover in the context of macrophages that we didn't see were expressing a lot of ACE2.
And neuropilin-1, is it expressed in normal atherosclerosis without SARS-CoV-2 infection, and does it play a role in the activation?
In the activation of
macrophages and foam cells or the actual
yes,
lesion?
Yes. We looked into normal lesions not infected as well. We also studied how neuropilin-1 is expressed in macrophages and in foam cells. And going back to what we were discussing before, the higher tropism of the virus for lipid-rich macrophages, we found that macrophages enriched or loaded with cholesterol were expressing more neuropilin, which we think is one of the reasons why the virus is capable of entering more in these cells. We also found that foam cells have a different response to the infection. And we saw that one of the most important early on antiviral response that the cells can operate is interferon response. And foam cells had a lower ability to produce interferon in response to infection. So this implicates the cells in the context of atherosclerosis as important factors that are capable of being infected, but also potentially representing one of those cellular reservoirs that could be responsible for lingering the virus in the vascular system. And so we are very interested now in understanding the long-term implications of these very early discoveries.
Maybe we'll end with that. So where do you think you'll take this work now?
Well, I think that, you know, as I mentioned in the beginning, it's very important for me to continue this work that I think is very relevant for a lot of people that were infected and are still experiencing long COVID. And at the same time, it offers the opportunity to the scientific community to start thinking about viral infection or pathogens at large as modifying disease factors that we really need to think about whether they are relevant for the disease and how and what can we do about it. And in the context of several cardiovascular risk factors that we all know about, we're learning more and more things. For example, somatic mutations that we accumulate over time. And I think that viral infections are part of the equation, and it's important to be aware of it.
Do we know of any other effects of cardiovascular risk factors on neuropilin expression?
Neuropilin expression, not really. It's something that we are studying. We know that neuropilin is an immune checkpoint in a way, and it's important in responses to inflammatory responses of the body to sepsis, for example, and it regulates this response. And in fact, it's something that we want to understand better mechanistically with or without viral infection. I will also add that, you know, thinking about what we learned from the pandemic and how we can take this knowledge into the next step, the interaction between infections and cardiovascular disease is not new. And we all know that the influenza increases risk for cardiovascular events. Right. And we also know that HIV infections increases risk for cardiovascular events. So putting all these pieces together and considering also SARS-CoV-2, I think that there is enough evidence to, you know, work more as a community into understanding these interactions.
Well, thank you very much, and congratulations again.
Thank you. Yeah.